Okay, guys, so this is section 17.1, part 2. Okay, so second lecture, we're talking about compound inequalities. Now, what we're going to focus on, we're going to focus now on solving inequalities of the form a is less than x and x is less than b. Okay, so this is how you read it. You can read as x is between a and b. What that means that, and here this is what I'm going to do. I'm going to break this down into two inequalities. So here I'm reading from right to left, means x is greater than a, and this is the second inequality, x is less than b, and x is less than b. So look what happened. We already know that word and means intersection. So technically we have two inequalities put together and we need to find the intersection. Okay. So the solution set will be the intersection of both inequalities. Okay. So let's do the example. We need to solve the inequality -6 less than equal 2x minus 5 less than 1. And I know that I teach you in section 10.8 that you technically can isolate x in the middle and do the operation 3 times, one in the middle, one in the left, one on the right side. However, when you have inequality like that, I recommend it to rewrite as a two inequality, because if you have negative coefficient in front of x, sometimes you may forget about switching that sign. So I think it will be safe, and I'm going to solve it that way. For you guys, it will be safe to rewrite as two inequalities. Which, again, the first one will be this one. So I'm going to read from right to left. 2x minus 5 greater or equal to -6. Okay, so this one means you read from right to left. 2x minus 5 is greater or equal to -6. And the second inequality is 2x minus 5 is less than 1. Okay, so we're going to solve two inequalities. So step 2, solve two inequalities. Solve both inequalities. Okay, so we're solving for x. We have both inequalities. We know that and means intersection. So I will add 5 to both sides because you want to isolate x. And you have 2x greater equal -1 and just divide each by 2. We're getting x greater equal -1/2. And we're going to solve the second inequality. The same thing, we need to move -5 to the right side. So we're going to add 5 to both sides of the inequality. We're having 2x less than 6 and divide each by 2 and you're getting x less than 3. Okay, so we have two solutions of both inequalities and means intersection. So we're going to look now for intersection. So step 3 will be find the intersection of both inequalities. So we already know what to do. We're going to graph both inequalities on one number line. The first one will be in orange. So we have x greater equal -1/2. So close the circle and shade everything to the right. Okay. The second one will be in green, x less than 3. So open circle and I'm shading everything to the left. And intersection, it's when two inequalities overlap. Okay, intersection means overlap. So the solution set is from -1/2 bracket, because we're including -1/2, up to 3 parentheses. Okay, so this is end intersection. Okay, so compound inequalities, again, I recommend it to rewrite as two inequalities and solve them separately. Let's do another one. So the second example, different example. So let me just put that this one was example A, and I will do example B. So we have 8 greater than t plus 4 divided by -2, and this is greater than -5. So what I'm going to do, step 1 is rewrite as two inequalities. So the first inequality is this one. Okay, so don't forget that this one means, because you guys want to have the number on the right side, means that read from right to left. Again, t plus 4 divided by -2, and again is less than +8. Okay, so again, I'm not switching inequality sign, I'm just putting t plus 4 like you see, pointing to t plus 4, pointing to t plus 4. Okay, and we have second inequality, which is right here. T plus 4 divided by -2, it's greater than -5. Okay, and we're going to solve both inequalities, and we remember that N stands for intersection. So let's solve both of them. Here we have a fraction, so what you want to do, you want to multiply both sides by -2. So I have -2 times original left side of inequality, which is t plus 4, divide by negative 2. Look what happens. Since we multiply by negative 2, the inequality have to reverse. You have to remember that when you multiply or divide by negative number. And then we have negative 2 times copy the right side of inequality. So negative 2 and negative 2 cancel, and we have t plus 4. It's greater than negative 16. Subtract 4 from both sides, and we having t is greater than negative 20. So that's the first solution. And we need to solve the second inequality. So the same idea, we're going to multiply both sides by negative 2. So we have negative 2 times the left side of the inequality, t plus 4 divided by negative 2. And because we multiply by negative 2, inequality will reverse to less than. And we have negative 2 times negative 5. So cancel, we end up with t plus 4 is less than 10. Subtract 4 from both sides, and we having t, it's less than 6. Okay, so we have those two. T, it's greater than negative 20, and t, it's less than 6. Next, what we're going to do, we're going to graph them together on the same number line. So the first one will be in orange, t greater than negative 20, negative 20, greater, like you see, the direction of inequality match with the direction of number line. The second one, it's t less than 6, less than, so we're putting 6 here, direction of inequality matching with the direction of the number line, so we're shading everything to the left. And end means intersection, so intersection of both inequalities, it's the part which overlap, and like you see, they overlap right here. So the solution set is from negative 20 to 6 in parentheses because both have open circle. Okay. Next, what we're going to do, similar work, but we're going to solve inequalities which have word OR. Word OR stands for union. So now, the next examples, we're going to add the solutions together. So AND stands for intersection, remember that. AND means intersection. Now we're going to work on union, which means addition of two inequalities. So this is new. Solving compound inequalities. With R. Remember, R means union, which means adding solutions together. So we're not looking for intersection right now. We're looking for union. We're adding solutions together. So note means union. Again, don't forget, note again, R equal to U, and that means union. Okay? So how are we going to solve it? Steps to solve compound inequalities with R. Okay, word R, union. So first what you're going to do, solve each inequality. Second, we're going to graph the solution sets of both inequalities together. on a number line. The third step is find the union of two solution sets. Okay, so find the union of two solution sets. So we talk about it. So union means that will be now the part of number line which is shaded. Not intersect. Entire part of number line which was shaded. It doesn't matter which color, but it has to be shaded. Okay, and the fourth step, express the solution in interval notation. Or set builder notation. Okay, so let's do examples. So solve compound inequality with word R. So remember, we're looking for union now. So first example, we have negative 10x minus 8 greater or equal to 12, or we have second inequality, which is 3x minus 6, it's greater than 3. So step number one, we're going to solve two inequalities. I'm solving the first one. That negative 8 has to be moved to the right side, so we're going to add 8 to both sides. We have negative 10x greater or equal 20. And to isolate x, you're going to divide both sides by negative 10. And when you divide by negative, don't forget to reverse inequality. So we end up x less than equal negative 2. So that's the first one. The second one, we're going to solve for x. So negative 6 has to be moved to the right side. You see negative 6. So add 6, which is the opposite. That will give you 3x greater than 9. And divide each by 3. That will give you x greater than 3. And of course, we have word R. So we have two solutions set. We're looking for R, which means union of both solutions. So how are you going to find it? The best way will be, and that's what I want you to do, grab both solution sets on one number line. So the first one will be in red, x less than equal negative 2, negative 2. We have equal signs, so we're including negative 2 as a solution, and we're shading everything to the left. The second inequality, let's do it in green. We have x greater than 3. So we have 3 greater, not equal signs, so open circle, and we're shading everything to the right. Now we're looking for union. So union is the solution set of the first inequality and solution set of the second inequality putting together. Union means add two solutions. We're adding solutions. Okay. So in the notes, I told you that the union always will be the part of number line which is shaded. It doesn't matter which color. So this is shaded and this is shaded. So that's my union. Okay, so union, okay, part of the number line which is shaded. So you're going to express the solution using interval notation. That will be, again, this is always negative infinity. Here you always have positive infinity. So it's from negative infinity to negative 2, bracket, union, because we're adding the second solution. from 3 to positive infinity. So that's the difference. When you solve two inequalities, which means compound inequalities with word or, the solution is the part of the number line which is shaded. Okay, they don't overlap. Okay, they don't have to overlap. Okay, everything what is shaded on the number line will be your solution. Okay, and I want to do one more. Let's do B. So let's practice what we learned. So we have two inequalities, x minus 7 greater than negative 2 or negative 6x greater than negative 48. So we're going to solve both inequalities. I'm solving the first one. I'm adding 7 to both sides. That will give you x greater than 5. And I'm solving the second inequality. Here I need to divide each by negative 6. Since I'm dividing by negative, I'm reversing inequality symbol. And that will give us 8. So we have word or. So we know that we're looking for union. Here we're looking for union. So when you solve them, we're going to graph both inequalities together. The first one will be in green. X greater than 5, so this is 5, open circle, and I'm shading everything to the right. The second inequality, I will shade it in green. X less than 8, so this is 8, open circle, and I'm shading everything to the left. Okay, so R means union. We're looking for union. We're adding the solutions together. For union, your solution is the part of number line which is shaded. So look what happened. We shade entire number line. Okay, so that means this is our solution. Okay, the solution or union means we adding solutions together. Since we shaded entire number line, so the union will be the interval from negative infinity to positive infinity, with all real numbers. So that's our solution, entire number line, from negative infinity to positive infinity. And again, this is more than fine. Okay, when you're solving with union, you may see the solutions like that. We shaded entire number line. This is the solution. And what I want to do next, I want to do applications with compound inequalities. That will be next. Applications of compound inequalities. Okay. Application of compound inequalities. So let me start with hint. Word between means, if we're talking about inequality, that x is between two numbers. So you're going to have number here and number here. And word strictly between. That between means strictly between two values, strictly between two values. The endpoints are excluded. Okay, so let's do example. So that's the hint, but you guys will see where I'm going with that. Translating. Compound inequalities. Okay, so the first one is the length of normal human pregnancy we're going to use W for that, F stands for week, is from 37 to 41 weeks inclusive. So first what you need to do, A, write inequality representing the normal length. Representing the normal length of pregnancy. Okay, so we have inclusive. That means we including 37 weeks as a normal pregnancy week and 41 weeks as a normal pregnancy week. So W stands for weeks. And the answer will be, this is compound inequality between 37 and 41. Inclusive, that's why you see the inequality and equal sign, because we're including that, we're saying that 37 weeks, it's normal, and 41, it's also normal. So 37, 38, 39, 40, and 41, that's the regular pregnancy week. B will be write a compound inequality representing abnormal length for a pregnancy. So to do that, let me go back to part A and let me graph so we can see better on the number line that regular pregnancy. So the normal pregnancy is between 37 and 41 weeks, right? So between 37 and 41 weeks. And we, of course, including those numbers. Okay, so this is normal pregnancy. Okay, so abnormal pregnancy will be everything else. Okay, so in red, this is abnormal and this is abnormal. Okay, so this is abnormal. Okay, so in red, that will be abnormal. In red, abnormal length of a pregnancy. So using compound inequality, what I'm going to say that abnormal length of pregnancy is going to be X less than 37 weeks, or, because we have two different sets, so that means we're adding the solutions, or X greater than 41 weeks. And of course, here we should give a little more restrictions, because again, it should be less than 37. But again, it doesn't make sense to talk about negative. So it should be from 0 to 37. and greater than 41. So again, we know that we cannot have a pregnancy like 50 weeks. I never heard something like that. However, they not really go so deeply about it. They want to write abnormal length of pregnancy. So that's everything else except 37 through 41. So that's the abnormal pregnancy. Okay, and can do one more example, and that will be the last example. So let's do this one. The sum of twice the sum of a number, so that's a different example, and 11 is between 21 and 31. So all the time when you see between, we're going to talk about that compound inequality. X is between two numbers. Find all such numbers. Okay, so that's the next one. The sum of numbers of a number and 11, it's between 21 and 31. Find all such numbers. So this is what we want to do. So hint, we talk about between. When you have between, that means you have x between two numbers. So that's what we're going to do. Or expression, doesn't have to be x, okay? So here what I'm going to do. First, I'm going to label my variable. So x, it's going to be a number. Okay, x is a number right here. That's my x. So I'm reading the sum stands for plus, of a number, which is x, and 11 is between 21 and 31. So between, that means this sum is between 21 and 31. So we're building that compound inequality. And we need to find all such numbers. So again, it's not one solution. So what we're going to do, solve compound inequality. You have to solve for x. So we have compound inequality. What I'm going to do first, I'm going to break it down into two inequalities. Okay. So this one is the first one. Paste. So don't forget that this inequality, oops, don't forget that this inequality means, read from right to left, that x plus 11 is greater than 21. And when you have inequality like that, we're using word and. We're looking for intersection. And the second inequality, which is x plus 11, it's less than 31. Okay. So we're subtracting, let's solve this one first. We subtract 11, so we're getting x is less than 20. Okay. Here also we subtract 11, and we're getting x is greater than 21 minus 11, that will give you 10. And of course, and. So we have two solutions, and word and stands for intersection. So I'm going to graph it. The first one will be in orange, x greater than 10. So shading everything to the right. This one will be in green, x is less than 20. Shading everything to the left. And n stands for intersection. So the solutions are numbers between 10 and 20. So the solution set are the numbers from 10 to 20, between 10 and 20. You not include 10 and you not include 20. Or if they will ask you to write the solution using, this is interval notation. If you need solution writing using set builder notation, so let's review that because we didn't do it, will be that the solution set are all the x's such that, and here you have, when you have interval from 10 to 20, you can use the word between. X is greater than 10 and less than 20. Okay, so this is the set builder notation. So all the numbers from 10 and 20. Okay, that's it. So this is the end of section 17.1, lecture 2. Thank you for watching, guys.